Welcome to LIB Academy. My name is Adams, and I'll be taking you through introduction to quantum mechanics. Your smartphone, your laptop, all work under, quantum mechanics. They work because of quantum mechanics. So it turns out to be like there is a need for us to dive deep into quantum mechanics. So before we continue, this video is part of my playlist, and I'll be numbering the videos. You can kindly follow the video step by step to broaden your understanding on quantum mechanics. So to begin with, let's look at what classical physics is what exactly is classical physics before we look at quantum physics. Well, we can call it quantum physics, quantum mechanics, or modern physics, all holds. So in classical physics, we are dealing with things at the macroscopic level. Things tend to be moving at lower speed as compared to quantum mechanics. One of the important things under classical physics is the Newton's law of motions. In classical physics, we can analyze a moving ball or a falling object directly, or planet orbiting the sun. We can analyze them directly. Directly means here we can observe them and make deductions. Mathematical deductions. So for instance, if we have a moving car and we know its initial velocity to be u and the final velocity to be v, and the time taken by the car to cover this final velocity to be t, we can calculate its acceleration according to the Newton's law, right? That is in the classical world. So a moving ball, a falling object. So basically, classical physics explain how everyday object moves, interacts, and respond to forces, right? So now we want to know deep about how things are made up, right? And we are diving deep into matter. So now we want to look at the building blocks. What is happening at the building blocks? Therefore, quantum mechanics comes in, where we'll be dealing with things at the microscopic level, the atomic and the subatomic level, right? So that is basically what quantum mechanics is about. So the aim of quantum mechanics is to describe and predict the behavior of matter and energy at the smallest scale, which is the atomic and the subatomic level. Basically, the study of matter and energy at the subatomic level. Atomic and subatomic level. We are dealing with things at that place. Electrons, protons, and so on. Right. So in the classical world, we can calculate the momentum of a moving object, the force of a that will be exerted on an object. We can calculate a projectile, but it turns out that we cannot transform all these laws and formulas into quantum mechanics directly, because things tend to behave differently, slightly different in the quantum world. And this is because in quantum mechanics, we know that since we are dealing with subatomic and the atomic level, and at that place, we know that particles behave like waves. So because of that, outcomes becomes probabilistic instead of definite. Well, I wouldn't like to continue very much with this video. We'll meet in the next video, or we'll talk about operators and observables. To know much about 3D and 4D, you can kindly check my video on that. Once again, this video is part of a quantum mechanics playlist, and this happened to be the first video. Feel free to check the others out. If you found this video helpful, kindly subscribe to my channel and give a thumbs up to this video for more educational content like this. You can also refer my channel to your friends. Thank you. Bye. Thank you.